بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتطرق إلى درس جديد بعنوان سنتر أوف جرافيتي، مركز الثقل. طبعا مركز الثقل ده من الدروس المهمة جدا جدا في علم الميكانيكس وخاصة علم الاستاتيك. طبعا احنا عارفين علم الاستاتيك هو علم السكون، وطبعا احنا عارفين ان الأرض لها مركز ثقل، وكل جسم أو ريجد بادي، جسم صلب، بيبقى له مركز ثقل. كل جسم أو كل مادة بيبقى لها مركز ثقل، بسميه سنتر أوف جرافيتي. السنتر أوف جرافيتي نقطة ثابتة، يعني الإنسان بيبقى له مركز ثقل لأنه جسم بادي. أي جسم فيه موجود على الأرض بيكون له سنتر أوف جرافيتي fixed point in space، في الفراغ، except the center of earth. The line of the center of the earth يعني بمعنى الخط يتصل بين مركز الأرض ومركز الجسم أو مركز ثقل الجسم الموجود. موضوع النهارده موضوع مهم جدا جدا لطلاب الثانوية العامة، وطبعا احنا عارفين اليونت الأخير في السنتر اوف جرافيتي ده اتلغى السنة اللي فاتت نظرا للظروف اللي كانت موجودة، ولكن هو موجود معانا هذا العام. Center of Gravity. Welcome, my dear student, in our math program in secondary 3. Today we are taking a new lesson in static subject. Its title, Center of Gravity. What is the center of gravity? What is the definition of the center of gravity? What is the point which represent gx and gy? My dear student, look at introduction about the center of gravity. Center of gravity. Definition. The center of gravity of a rigid body is a unique point. Unique point in space except the center of the earth. Remember, my dear student, understand this definition. The center of gravity of a rigid body is a unique point in space except the center of the earth. The line of action of its weight passes through it and it is fixed whatever the position of the body change with respect to the surface of the earth. The center of gravity of a rigid body denoted as G capital. Remarks. My dear student, the first remark, the line of action of the weight of rigid body passes through its center of gravity and the center of the earth. The center of gravity of a rigid body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. The position vector of the center of gravity of a rigid body with respect to the origin. My dear student, suppose W1, W2, 2Wn be weight of particles forming a rigid body. R1, R2, 2Rn position vectors of these particles with respect to the origin. Then the position vector, its symbol Rg, to the center of gravity of rigid body about the origin is denoted by the relation. Very important relation. Rg position vector equals W1R1 plus W2R2 to WNRN over summation of all weights W1 plus W2 to Wn. This equation number 1. Remember, what is the relation between W and Mg? W1 equal M1G, W2 M2G. What you mean mass G, this is 9.8 gravity force, but W is the weight, and Wn equals mng. Mn, m1, m2 to mn are masses of particle forming a rigid body. By substituting in equation number 1, then divided numerator and denominator by G, then we find Rg m1r1 plus m2 r2 to mn rn over m1 plus m2 to mn. The previous vector relation can be written in terms of components in the direction of the orthogonal coordinate axis OX and OY ray to get the following. This is very important rules. Component of the center of gravity, the first xg, m1 x1 plus m2 x2 plus mn xn over m1 plus m2 to mn. This is the first component of the center of gravity. Also, yg m1 y1 plus m2 y2 plus 2mn yn over summation of all weights m1 plus m2 to mn. This is the second component of the center of gravity. My dear student, now we are translate to solve example. Two bodies. The mass of each is 6 kilogram and 12 kilogram. Distance between them is 90 centimeter. Remember, my dear student, we have two bodies. The first mass is 6 kilogram, the second mass is 12 kilogram. Distance between them is 90 centimeter. What is the required? The center of gravity of two bodies with respect to the body 6 kilogram or the first body. Remember, my dear student, this example may be multi-choice, very easy to find the center of gravity by the rule. What is the rule? Look at solution. We have two bodies at origin point 6 kilogram, at point A 12 kilogram. Distance between them 9 centimeters. Therefore, my dear student, the origin point is 0, 0. The center of gravity of mass of 12 at a point A 90, 0. Then, by using rule m1 x1 plus m2 x2 over m1 plus m2 to calculate the value of x g. 6 times 0 plus 12 times 90 over summation 6 plus 12. Answer is 60 centimeter. We have two bodies. The first 6 is 6 kilogram, lies on 0, 0, but 12 or the mass 12 lie at the point A 90, 0. xg equals m1 x1 plus m2 x2 over m1 plus m2. m1 represent 6 kilogram, m2 represent 12 kilogram, x1 represent 0, x2 90, then xg equal what? 60 centimeter. YG by the same rule, the second component of the center of gravity m1y1 plus m2y2 over m1 plus m2. Then we deduce that the value of YG equals 0. Why? Because 6 times 0, 6 represent m1, 0 represent y1, 12 represent m2, 0 represent y2, over summation of 2 mass 6 plus 12, 0 over 18 equals 0. Then we deduce that, my dear student, the center of gravity 60, 0, or at distance 60 centimeter from the first body. The center of gravity at a distance 60 centimeter from the first body or mass 6 kilogram. This example very important. Remarks. The center of gravity of two particles where the distance between them, their centers of gravity is constant L, lies on line segment, join them and divides its length by inverse ratio to their masses. Very important remark. M1 over M2 equals inverse ratio of the segment or line segment. Example. ABC is a triangle. AB equals 6 centimeter, BC 8 centimeter, CA equals 10 centimeter. What you notice? AB 6, BC 8, CA equals 10. Three sides of right angle triangle. At what? At B. Why? Because CA equals 10 centimeter. D and E are midpoint of AB and AC. Then three equal masses, each is M, are placed at B, D, and E. Find the center of gravity of this mass. Solution. Look at, my dear student, this right angle triangle. AB equals 6 centimeter, BC 8 centimeter, AC 10 centimeter. The point D, midpoint of AB, its coordinate 0, 3. Why? Because coordinate we let the origin point B 0, 0, then point A 0, 6, point C 8, 0. Therefore, we deduce that midpoint of AB is the 0, 3. Midpoint of AC is E 4, 3. Why? 0 plus 8 divided 2, 4. 6 plus 0 divided 2, 3. This rule of midpoint. We have three mass. Each of them is M. At D, at B, at E. At M, its coordinate of D 0, 3. At D, at B 0, 0, at E 4, 3. We know that CA square equals summation of AB square plus BC square equals 100. Then triangle ABC, right angle triangle at B. We let BX, BY two orthogonal and is the origin point. Therefore, A06, C80, 803, E43 midpoints. It's better to form following table to represent the masses and coordinate of each. Look at the table. The first table represent the point at B, point at D, point at E. This point which all masses, three masses, lie on it. After that, mass at B, M, at D, M, at E, M. What is the coordinate of X coordinate? At B 0, at D 0, at E 4. Y coordinates at B 0, at D 3, at E 3. My dear student, we form this table. What you mean? The table, from this table, we find the center of gravity by using xg m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. It is easy to solve this problem of center of gravity. This table, we solve all problems about the center of gravity. The coordinates of the center of the system xg by rule m1 times 0 plus m2 times 0 plus m3 m times 4 over summation of 3m equals 4 over 3 centimeter, this coordinate of xg. But yg by the same rule m1 y1 plus m2 y2 plus m3 y3 over summation m1 plus m2 plus m3 equals what? 2 centimeter. Therefore, the center of gravity, its coordinate 4 over 3 and 2. Another example. ABC is an equilateral triangle. Its side length 12 centimeter. Mass of magnitude 3, 4, 5 grams are placed at its vertices A, B, and C respectively. Respectively, what you mean? 3 at A, 4 at B, 5 at C. A, B, and C, 3 vertices of triangle. 3, 4, 5, 3 masses. 3 at A, 4 at B, 5 at C. Determine the center of gravity of the system. Look at solution. My dear student, we put ABC as equilateral triangle. You know that, my dear student, equilateral triangle, 3 sides are equal in length, or 3 angles equal in measure. If we have the length of side of equilateral triangle as 12, then the height or the median drawn from the vertex and the opposite base equals 6 root 3. Why? It's very easy. Look at the opposite figure. The height divided BC into 2 equal parts. Each part equals 6. And we have AC equals 12. Then the height by Pythagoras theorem, 12 power 2 minus 6 power 2 equals 6 root 3. Then why we find the height? At the first, we can determine the coordinate of the point B, coordinate of the point A, coordinate of the point C. Also, my dear student, we let the origin point is B, or BX, BY axis represent the axis of the system. B origin point, C 12 0, point A 6 and 6 root 3. It is important to determine the coordinates of points which masses lie on it. Point B, its mass 4 gram. What's the coordinate? 0, 0. Point C, mass 5 gram. What is the coordinate? 12, 0. Point A, 3 gram. What is the coordinate? 6, 6 root 3. Then form the table. Look at, my dear student, this coordinate of B and C and A, hence the table for mass and their coordinate will be as follow. Look at the table at A, at B, at C. What is the mass? At A, 3 gram. At B, 4 gram. At C, 5 gram. What is the coordinate of X? At A, 6. At B, 0. At C, 12. What is the coordinate of Y? At A, 6 root 3. At B, 0. At C, 0. Then it is very easy to calculate the center of gravity by using the rule m1x1 plus m2x2 plus m3x3 over m1 plus m2 plus m3 by the same method to calculate the value of y coordinate. Coordinates of the center of gravity of the system xg 3 times 6 plus 4 times 0 plus 5 times 12 over summation 3 plus 4 plus 5. Then xg 78 over 12 or 13 over 2 centimeter 6.5. By the same method, yg m1 y1 plus m2 y2 plus m3 y3 over summation m1 plus m2 plus m3. Therefore, yg equals 3 root 3 over 2 centimeter. Then the center of gravity of the system, its coordinate 13 over 2, 3 root 3 over 2 respect to point B. Why? Because point B is the origin point. Another example. ABCD is square of side length 10 centimeter. Masses of magnitude 12, 8, 6, 4 grams are fixed at its vertices A, B, C, D respectively. Masses 20 gram is fixed at midpoint of AB. Determine the center of gravity of the system. Solution. My dear student, we suppose Cx, Cy are orthogonal axes as shown in the figure. Look at Cx, Cy. We have table at A, at B, at C, at D, at E. What's the mass? At A 12, at B 8, at C 6, at D 4, at E 20. What is the X? Coordinate 10, 10, 0, 0, 10. Y, coordinates Y 10, 0, 0, 10, 5. By using the rule m1x1 plus m2x2 plus m3x3 plus m4x4 plus m5x5 over summation of masses, we calculate xg equals 8 centimeter. By the same rules, yg equals m1 y1 plus m2 y2 plus m3 y3 and so on equals 5.2 centimeter. Then we deduce G, or the center of gravity, at 5.2 with respect to the point C. My dear student, by the end of the lesson, we know that the center of gravity, to calculate or to determine the center of gravity of rigid body by using rule m1x1 plus m2x2 plus mnxn over m1 plus m2 plus mn. Also yg equals m1y1 plus m2 y2 plus mn yn over summation of m1 plus m2 plus m3 to mn. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.